Welcome all of you to another video of Maths Made Easy. As I had promised, these are the important questions of ammonia. Now in ammonia, I have to tell you that it is not, in ammonia you have to study a little more. The number of equations are a little more, you have to give it a little more time. Okay, so because what I felt is there are more varied, ammonia is little more varied, but then ammonia I should say is the most happening out of all the study of compounds. It has the same it has the same fountain experiment with a different litmus color solution. I am not going into it, I have already explained the fountain experiment in detail. In this case you are only going to take ammonia and the litmus color solution will be red this time, because red turns to blue if it is an alkaline solution. So, and the red solution of litmus will spray out as a blue color. I am not going into that. Ammonia is highly soluble. Okay, so ammonia is highly soluble in water, just like HCl, which is highly soluble in water. Similarly, ammonia is also very much soluble in water. So the fountain experiment actually proves the solubility. Okay, other than this, ammonia, learn up the what is the meaning of liquor ammonia and all that. Okay, and then let's come to the equations. There are lots of equations. You'll see that they come in kind of pairs. It helps you to learn them up because they are coming in pairs. Let's see what I'm talking about. Okay, but the very first thing I want to tell about ammonia is the Haber's process, which is Haber's process. Now this Haber's process is the industrial method of preparing ammonia. Never miss the industrial methods of any of these study of compounds. Now here we have nitrogen plus hydrogen, which gives, now I can't put an arrow like this, it is a reversible reaction, okay, which gives ammonia. You can balance it. Okay, so here iron is used as a catalyst, very important. Molybdenum is used as a promoter. Okay, 450 to 500 degrees centigrade, that is optimum. Okay, you raise the temperature, you do get more amount of ammonia, but then there is a chance of the entire the setup of the production unit might develop cracks if you are increasing the temperature and also increasing the pressure. Okay, 200 to 900 atmospheres of pressure. Okay, 200 to 900 atmospheres of pressure. So these are the this is the most important reaction in your in ammonia. Okay, now here I want to say this equation is so special. Why? This is a catalytic reaction, it's a reversible reaction, it is an addition reaction. Okay, why I am telling you all this is it helps you to remember. Okay, so it is also an exothermic reaction, it does give out a lot of heat. So initially they start the reaction with some heat, but then later this heat only does all the job. Then it is a catalytic reaction, as you can see, one reaction which uses a promoter, and so there's a lot of this reaction is special in many ways. Okay, now what is the meaning of a reversible reaction? If you have not understood, it means these two will produce ammonia. If this ammonia that has been produced is not being taken out immediately, immediately, and it is being left in this setup, then under the same conditions, reversible, that means it now splits to nitrogen and hydrogen. Now we don't want it, we are producing ammonia for a reason we want it, so we are just after ammonia is produced, it has to be removed. Anyway, that is not something to do with your portions. So here this is so Haber's process. Other than Haber's process, what are the important reactions? I'll talk about the lab method. Mg3N2, this is very often asked, plus water. MgOH twice plus NH3. Now if you are producing ammonia, you can't forget that. Okay, only thing is you have to remember it is water. Then NH4, ammonium chloride, plus Ca OH twice, CaCl2 plus H2O and of course ammonia. Okay, so how do we remember it? We have to remember in one it's a nitride and in the other one it is an alkali with which ammonium chloride reacts. Okay, now these two reactions are asked very often. This comes under lab method of producing ammonia. Okay, remember these under lab method. When you are doing this lab method, you should also remember that it is collected by downward displacement of air. Okay, this is downward displacement of air. It is collected by downward displacement of air. So that means it is heavier, it is lighter, that means it is lighter than air. Okay, two equations, that's an absolute must now. That is oxidation of ammonia. Ammonia, okay, plus oxygen. This is without any catalyst. Okay, after that we'll do ammonia with oxygen but then platinum catalyst. This gives NO plus H2O. Here it is N2 nitrogen plus H2. This can become a little confusing, so try to remember. Here platinum catalyst and the temperature is 800 degrees centigrade. Here no catalyst, but then you have to remember something else. Ammonia burns with a greenish yellow flame here. Okay, so they can give it as a hint. So if it is greenish yellow flame, then there is no catalyst. If there is a catalyst, no greenish yellow flame. With catalyst, nitrogen gas. Without catalyst, nitrogen monoxide. You can balance them. So balancing is naturally going to be different. Now we are going to learn ammonium hydroxide. Okay, that is also, you can say, a solution of ammonia. Okay, ammonia with water will form ammonium hydroxide. It is a weak alkali. If you are asked to name a weak alkali, or you are asked in MCQ, ammonium hydroxide is a weak alkali and NaOH is a strong alkali. Okay, KOH is a strong alkali. Okay, so now FeSO4 plus NH4OH. As I said, there are some pairs. Just now we finished with the burning of ammonia. Now FeCl3. Easy to remember these pairs. Okay, NH4OH. Both is reacting with NH4OH. If you see here, this Fe has the valency, since Fe has variable valency, has the valency 2. Here Fe has the valency 3. That is what is going to make the difference in your answer. FeOH, how much? Fe was 2 here. Hence it is twice, plus NH4 and SO4 is 2, so NH4 twice SO4. Let's come to this FeOH thrice now. Why thrice? Because here we have taken 3 for Fe. Valency is 3 here. Okay, plus NH4Cl. Okay. Now these two equations are also there in your analytical chemistry. Now here, what is the color? Because they will not tell you the equation, but they will give you some other hint and mention the color. Okay, now where you have used valency 2, the precipitate is dirty green. Where you have used valency 3, it is reddish brown. This has to be remembered. Okay, so that is dirty green, this is reddish brown. This is what to be remembered. If you remember that, automatically you can think about this, because with SO4, if it's using, this is valency 2, so it's easier to remember. I know it's little confusing, but you have to remember the color of the precipitate when it is using valency 2 dirty green, valency 3 reddish brown. Okay, makes a lot of difference in remembering. We are going to do 3 more sets like this. Okay, sets of equations which help you to remember this chapter. Otherwise, all together, a bunch of equations together can make it very difficult for you. Okay. Reducing reactions, because ammonia is a reducing agent, like HNO3 is an oxidizing agent, like that. Okay, so ammonia is a reducing agent. Here I have copper oxide and I have PbO plus. So if I learn like this, ammonia, yeah, I'm writing like this because it helps to remember. Okay, then it is, of course, if it is reducing, it will be reduced to metals. So plus we have the H2O clearly, okay, we have H2O, and then we have N2, nitrogen given out. So how to remember? We have to remember this part is same. If it is reduction, then this is going to remain, the oxygen is going to go away, this is only metal, okay. And here you have to remember that otherwise it is, these two equations are pretty okay, they very easy to remember and very often asked. Color of this is greenish pink. They generally don't ask, but just in case. Now ammonia plus chlorine. Again, why did I write it again? Plus chlorine. Okay, never write only Cl. So this is excess here. Once we use excess of this and once we use excess of this, okay, then what happens? This gives ammonium chloride plus N2. Yes, ammonium chloride plus nitrogen. This gives NCl3 plus HCl. This is explosive. They can give it, they can ask like that. Explosive substance, yellow in color, explosive substance called nitrosochloride. Okay, so you see the clear difference. When this is used in excess, you are getting ammonium chloride. When this is used in excess, you are getting nitrosochloride plus HCl. This is something to be remembered, can't really help. This has to be remembered. So, but then it is very important. What happens when ammonia is used in excess? What happens when chlorine is used in excess? Again, I said one more pair of equations. Now, this is a very important equation. Copper sulphate plus NH4OH. Okay, this is when this is not used in excess. Then ammonium sulphate plus copper hydroxide. This is pale brown. Okay, now this is formed, but then where is the next set of equation coming? Now this, if you are using excess of this, then what happens? This copper hydroxide formed in the first step reacts with further ammonium hydroxide and now it gives an inky blue precipitate. Inky blue. Okay, PPT. I am not writing the name of the precipitate. It's not necessary because it is not in your portions. But then till inky blue you should know, and that is cupramine sulphate. Okay, even this name is not necessary, but then I just wrote inky blue PPT is given out. So from this pale blue it turns to inky blue when this has been used in excess. Okay, so more of this reacting with the copper hydroxide creates this. These are not two separate equations. This is the same equation, step 1, step 2. That's it. Okay, test of ammonia with Nessler's reagent. What does it give? Ammonia with Nessler's reagent gives pale brown color. Gives pale brown colored PPT. Okay, that is a test of ammonia. Okay, so this is it from ammonia. Do this and then do the rest, as I've already told. If you haven't subscribed the channel, please subscribe it, because after this I'm going to once chemistry and maths is over, I shall be uploading lots of other videos on physics, and also once ICSE and CBSE is over, I shall be starting to upload videos of 11th standard maths. Okay then, bye. Thanks all of you. Do not forget to like and comment if you have liked the video. Bye then.